business. Yeah. Okay, so hi everyone, good evening, good afternoon, good night, wherever you are. My name is Mosumala Olabelo, and I am the community manager of Testis Quarters. Yeah, who are we? Well, we are wonderful. We're Testis Quarter. Um, um, we are the most active software testing community in Africa, and we are focused on empowering, aspiring, and practicing product quality engineers with resources, support, and mentorship that is required for them to succeed in their career. I know that there are some of us that we might be new here, but we've been here for a very long time. I mean, you should know who we are. We are one of the, in fact, we are the most active in Africa. And yeah, we're here too. So let's move on. Yes. Okay, our programs. We have office hour, which happens every Wednesday by 1 p.m. If you missed the last office hour, you missed a lot because we brought in a professional to answer our questions, and it was a lot insightful. So don't miss the next one coming, because I know I don't even want to talk about the person that is coming next, because you guys are really going to be surprised on who is coming next. But yeah, let me keep it like that. We have Friday study body, which happens every 8 p.m. and we are having one now, which is webinar. We have the global AMA fireside chats, first Saturday monthly. So every first Saturday of the month we have the AMA. Yeah. That is Ask Me Anything. We bring in any professional and you can ask anything. We have the local community quarterly hangouts. That is, we had the NSTW and funny thing, quarterly hangout. We have the APEC coming very soon, very, very soon. You might think next year is far, but we are here already and we're so excited to check into the APEC 2026. Oh God, I look forward to that. Scholarship boot camp. Yeah, we do have scholarship boot camp in our community, and you don't want to miss it. We have the mentorship annual gathering, test and on. We are also available on IG, LinkedIn, X Live. We have fun, comedy, and movie nights. If you also miss that, my guy, we have the test merchandise. Okay, let's move on. Now, from the bottom of our hearts, we want to appreciate new people that are joining us for the first time. I know that there are some people that join us from, let's say, last week to this week. You're very welcome to our community. We are so glad to have you here. And to be honest, we love you and there is nothing you can do about it. Yeah, we do love you. We do love you. Now let's move on. We have our speaker for today. I think some of us should know this woman. Yeah, this beautiful woman. She has been part of Texas Quarters for a long time, and I mean, I always look forward to our webinars because it's always insightful. You learn a lot. So the topic we're going to be having for today is vulnerable. Hey, Jesus, I don't, I don't know why this is like this, but let me just say it's vulnerabilities assessment and security risk analysis of agentic AI and RAG retrieval, or that is the meaning of retrieval augmented generation. Yeah, I want to introduce our speaker right now. Our speaker is Savi Grover. Savi Grover is a senior QA automation engineer with extensive expertise in software testing, automation frameworks, and quality assurance strategies. With professional experience at Ford Motor Company and across multiple domains, including media content management, autonomous vehicle system, payment and subscription platform, billing and credit risk models, background verification, and e-commerce. Service has established a strong track record of driving end-to-end product quality. Beyond industry work, Savi is an active researcher and thoughtful leader. Our academic contribution focus on emerging intersection of AI machine learning, and QA with balanced agile methodology. Savi is also a conference speaker and keynote presenter, creating structured talks, technical slide deck, and demonstration on QA productivity in agile organizations, AI driven testing methodologies, and automation strategies for evolving software systems. With a keen interest in efficiency, automation, and innovation, our, our work bridges both practical implementation and scalability, helping organizations and research communities advance with the future of intelligent software testing. It's so nice having you here, Savi. It's very nice having you here. Um, you can unmute the mic and talk. Okay.
Thank you, Marjanmala.
Yeah.
Let me share my screen.
Okay. Please, let's do well to appreciate her while she is coming up. I mean, it's not easy. Okay, over to you. Over to you. It's so nice having you here. Over to you, Savi.
Thank you again, Marjanmala, and thank you for the great introduction. As you all know, I'm a senior quality assurance engineer working for NBC Media right now, and previously worked for Ford Motor Company in various domains, which Marjanmala just introduced. So, not going over to introduction again. And moving on to our topic, vulnerability assessment and security risk analysis of multi-agentic AI and RAG systems. So, uh, first of all, we are going to start from basics. We will get to know what is LLM, what is ChatGPT, how these systems are different from an agentic system, and then what is a multi-agentic system, what is RAG, and how can we place all these pieces together in the AI landscape. It's like a puzzle. So you need to know what is what. You need to know which piece goes where. So starting from the basics, as we know what is an LLM, I'm sure every one of you must have interacted with ChatGPT. You must have asked a question, a query, and ChatGPT must have returned some answer after thinking about it. So ChatGPT is just an example of large language model, and it is made up of two things. One is an interactive application, and one is a thinking model. And here the name of the model is generative pre-trained transformer model. And there are some other companies also which have their LLM. For example, we have Claude from Anthropic, we have DeepSeek from DeepSeek, we have Gemini from Google, we have Llama from Meta Labs. So all these things are different kind of LLMs. Their basic task is to think about a query, retrieve results from web, or think about it, whatever they have learned based on whatever information they have learned in the examples before, and retrieve you a result. Now, this is a basic LLM. This is how a basic LLM function. So, and a user sitting at the application, he sends request entered by a user to a thinking model and receives a response, which is a generative text. We don't know if the response is accurate or not. It's just how the model thinks. If the model has been tremendously trained well, it can even give you accurate results, but that's how it functions. It may or may not be accurate, but it's just answering you like a human answer you. And you must have noticed there is no action. That means if you ask GPT, can you show me all the flights from New York to London, it will retrieve all the list of all the flights coming in. It will even give you an informative answer as to what you should book, but it will not book anything on your behalf. It will just retrieve information and render onto your screen. So there is no action, there is just generative text response. So moving on to what is an agent. So an agent is a thinking capability of LLM combined with a task. So in this picture, if you see, if a user is working directly with an agent performs a task of booking a flight itself, right? For example, a user has written, if I want to fly from Singapore to North London, can you book me a flight based on these requirements? Either I want a luxury flight or a cheap flight, or these are my sitting requirements, these are my meal requirement. Can you book, see and check, verify different flight portals, book on my behalf? You know my information, my name, my passport number, everything the agent knows, and just book on my behalf because I don't have the time to book. So this is a basic difference between how LLM works and how an agent works. Agent will do a task for you, it will make a decision, and it will be a goal-driven behavior. You have to provide your preferences, and in return, if you see, the agent has gone onto this third-party portals, compared the different prices, returned what could be the best flight for you, and return you a complete itinerary that this is the airline, this is the flight number, this is the departure date, arrival date, class economy, seats, meal preference. So happens when you book a flight with the AI agent. So moving on to what does an agent connect with? So agent can connect with the user, an application. It can also connect with the model for its thinking purpose. It can connect with ChatGPT. It will connect with one or more databases also based upon organizations. If organizations have a lot of data, it will think through the database, find out the result of your query, and it has its own memory. And an agent can also interact with third-party APIs. So in our case, all the external booking portals were third-party APIs, and an agent has the functionality of interacting with everything, third-party APIs, LLM, user itself, and come up. It also has its own memory somewhere. Okay, so this is how an agent is defined. Now going on to a real world example of agent, how in dev systems agent is worked. For example, a developer just have started using an agent and he wants to know that there is a missing button on the UI. Can you help me identify when and how this change occurred and share me a plan to revert that change? So an agent will go inside the Git changes, it will go inside database, old backend databases, it will check the front end code, and it will showcase, okay, this commit was done and this hampered in the missing button in the UI, and therefore you need to revert it. So this is a coding agent which is helping a developer to sort through how a bug occurred or how we can revert it. Just an example. So moving on, what is the complexity of working with agents? How agent do a task? We know that agent booked our flight, but how did it book our flight? It booked from using third-party APIs. So if you see in this case, all the third-party APIs, they have a different template for communication with their APIs. For example, this Joy Air has flight number, origin, destination. Drac Air has flight num from to. Ergo has flight start and finish. So all these parameters are different. If it has to interact with different portals, different third-party portals, it needs to know all these communication protocols differently, then only it will interact. So this is a drawback of agent. Agent cannot do this. So now, does the agent need to learn all of this? So the answer is no. It will not learn any of this. For their communication protocol, we use MCP, which stands for Model Context Protocol, for better understanding, better decision making, for choosing the right API at the right time. We use MCP. So what is the MCP here? So MCP is a third party API response mechanism. So here, if you see, between the agent and between the third party APIs, we have integrated our MCP model. This is like a communication protocol also, and it also sets the context of the user request. Suppose user is asking 2 flights, one from London to Singapore, one from Singapore to London. So MCP understands what is the context. One flight is a destination arrival, and one flight is coming back. Okay, so both the things, the communication protocol is also set and context of the request is also understood by MCP, and therefore the agent can make better decisions. So for example, if you see here, all these APIs are first going through this MCP template. Okay, MCP sets a common template so that the agent does not have to sort through all the results, all the third-party API results. It will set one common communication protocol between the agent and the third parties. So going on to what are the benefits of this MCP. So if you see a common architecture of MCP, this is a client, this is AI model. We see MCP sitting somewhere between client and model, and it can have different layers. It can have a context manager, which will filter out what is the context, user request context. It also has protocol handler, which will find out what is the communication protocol, which API to choose, which API to choose the decision making, and how to return the response to the client. So a model interface also means it will also have something with it will also have the knowledge of how to interact with customer, even the client application. So it has all these learnings within MCP. And if we see here, what are the benefits of MCP? Mainly establishing standardization, replace fragmented custom integration with single unified protocol. Write an MCP server once. You have to just write it once, and it can be reusable. If you have 3 airlines to compare with, you can have 5 also to compare with. You have to just use this common one MCP. So you can see it's easy to scale. The architecture is easy to scale. It supports various methods like HTTP requests and WebSockets. It's also secure because it provides a secure, controlled way of API communication. You define exactly what the AI is allowed to do narrowly, and it also has scoped permissions, reduced risk, flexibility, no vendor lock-in. There is no API which can lock your MCP because your MCP is defined at your end. It just have to interact with the third-party APIs, but there is no locking. There is no communication breakage. It's an open standard. You can easily switch between different AI models. If you want to remove your model, replace it with Gemini, go ahead, replace it. Just set in your MCP server connection with Gemini. And it enables a true agentic behavior by giving models a reliable way to interact with world and chain tools together. So it's a foundational technology for the agentic behavior for the AI agents. So now what is multi-agentic behavior? Now, so far we learned how our MCP server guided this agent to get to know what is the cheapest, what is the optimized flight, and book it. Now, if the user also wants to book a hotel, there are 2 agents doing it, followed by agent 1 result. You can't book a hotel first after booking, before booking a flight. So this is a series response. So agent 2 has to know that agent 1 is done booking the flight, and now it is in communication with agent to agent interconversations. It has all the user preference, what are the amenities, how many beds, what is the check-in time. It will similarly interact with different third-party hotel APIs, do a response, and book hotel for this user. make the decision itself and based on the goal-driven behavior. So this is called as agent-to-agent protocol, where two agents talk with each other. Okay, so this agent-to-agent protocol is recently developed by Google. And in this case, this is flight agent 1, this is agent 2. What are they communicating about? What can you do? Can you search and book hotels? So here is a task for you. Search for the best hotel in London. I shall search and get back to you with the results. Here is a list of hotels. These are the collaborative factors which they talk about: capability discovery, task management, collaboration, user experience negotiation. Of course, agent 2 has all the knowledge that what agent 1 has done, and it will synchronously interact with agent 1 in order to fulfill the user requirements. Okay, this is called as multi-agentic system or multi-agentic workflow. It's a very simpler example, but in a real world application, we have a series of agents doing different tasks, and we have to deploy them in an application. So going on to what is RAG. RAG is a part maybe within an MCP in order to have more optimized query. So in our case, we just have one basic requirement: book a flight and book a hotel. We don't have to consult any documents within if the user has, right? Suppose there is a company which has a lot of documents, a lot of contracts. Suppose there is a real estate company, it has a lot of contracts, it has different rental agreements with people, different buying agreements with people, and it has to sort through, their LLM has to sort through all those documents in order to retrieve the query and the response. Okay, suppose a contractor or a real estate agent asked, can you retrieve me the contract conditions of customer A? Now this will be confused. What is customer A? What are the contract conditions? So it has to have access to all these documents. It has to understand the documents, which is called as semantic search, means understand the documents based upon the meaning of the documents. And we maintain these external documentation in a vector database. Okay, and this vector database is consisting of different embeddings, different knowledge bases. It consults with it. Also, it thinks about it. It's not like it's blindly going to the database. It will think about user query, and it will consult with going to accurately indexed document and retrieve the result and give it to the user. Okay, it will do semantic search over here, find the related documents, again go to LLM, query the user inquiry and find the relevant documents, and then it will finally give the response. So this is called as retrieval augmented generation. Why? Because LLM is not blindly giving you the results. It is thinking through your documents, which you have provided to it. It could be a PDF. It could be a large database made up of tables. It could be any kind of documents, but it has a system to understand it using vector, DB, and embeddings. Okay, so user asks something to LLM, smart, it does the smart search, it will think about it. It will also go to the data or the memory which you have provided, finds the relevant info, thinking about it, and then finding and giving you an enriched answer. Not doing blindly search, not giving you blind answers, but giving you answers out of your documents. So how can we now place all these things in the puzzle? So again, summarizing, for the LLM, we just have a prompt, we just have one answer. For RAG, our prompt is cleaned with context as well as with memory, as well as with data. And then the LLM thinks and gives the answer. But for an agent, it has its own data memory, it thinks also, but it also have tools, it also have APIs to do an action on your behalf, and then it will retrieve and give you the results or do the action for you. So this is the difference between LLM, RAG, and agent. Okay, again, let's see how this puzzle is keeping different systems together. So this is a user, it's asking something with the model. Okay, the model thinks, try to reason it, and sends it further to RAG systems for maybe vector DB lookup, maybe the answer is locally into your documents. If not, it will do a web search, find you that document. If not, it will do a other external APIs to do that. So all of this is for better context. Okay. And now it comes up with a decision, but it has to still think, is the decision a task? Was the user requesting a task? If it is requesting a task, it will go to different MCP servers, interact with different agents, perform the task, give you the final response. Okay, this task is done. If it is just a text-based decision, it will finally give you the response. Okay, so this is how we use and integrate different systems together in an AI landscape. So going to what could be the vulnerabilities and common attack between all these components. So if you see this picture, this is a general idea of what kind of attacks, what kind of QA measures we need to take in order to protect these things. For example, we have a security attack, which consists of adversarial attack, prompt hacking attack. Adversarial could be backdoor attack, poisoning attack, prompt injection, jailbreaking. We will read about all of these components now. And we also have a general privacy attack where user information can get leaked, membership inference attacks. We also have gradient leakage attack. All these are based on user privacy. Different parts, information related to user can be leaked into the system, maybe from network packets, maybe from hacking perspective. All these are systems are vulnerabilities. So going on to what is prompt hacking. Okay, we read prompt hacking here. It involves strategically designing and manipulating user prompts so that it can influence LLM's output, while prompt injection is an approach to seize control over language model. So prompt hacking, we are manipulating the input prompts which are given by users. Somebody is breaking into the system, maybe because of open API keys, maybe because of secrets leaked, and it is modifying the input request. Prompt injection is modifying the output generated by the model. Then jailbreaking is defined as a general template used by bypassing restrictions. So jailbreaking is somebody is using a template to get into the system and modify the results. Backdoor attacks on LLMs can be broadly classified into poisoning attacks, weight poisoning, hidden state manipulation, chain of thought attack. Chain of thought attack is a well-known attack which occurs in autonomous vehicles. If somebody breaks into the system and the car is being driven on a particular lane, but its chain of thought is completely broken down and it interacts in a very fuzzy manner and out of control manner. Okay. Then data poisoning, it involves injecting malicious triggers such as rare tokens, different API key, different API client tokens, which are irrelevant to our application, and therefore somebody can control the output or inference. Then going to prompt injection and goal manipulation. Attackers can inject malicious instructions or prompt into the agent data stream or memory, altering its objective, its behavior, such as leaking sensitive data or making fraudulent transactions. So in credit risk, we have these kinds of failures, and that is why it's a reason why agentic behavior is still not very prevalent in credit risk applications and background verification applications, because information is very sensitive. Then memory poisoning. Adversaries can inject false, misleading data into agent short-term, long-term memory. Agent then interact with the corrupted data for truth, leading to stealthy manipulation of decisions. Memory poisoning here means whatever agentic memory is there, somebody has ingested wrong intents into that memory. Tool misuse here means APIs are manipulated. Suppose emails are manipulated, calendar invites manipulated. It can be tricked by using these tools maliciously. If you want your agent to book you a meeting, for example, and somebody has hacked into your calendar, your email, that will not go as planned. So a compromised agent could send phishing emails, schedule meetings with malicious domains, execute unauthorized code. These are some of the examples of tool misuse. Then what could be the security threats? First of all is privilege compromise. Agent can operate with elevated privileges or inherit user permissions. Okay. If compromised, then attacker can leverage all these information, leading to privilege escalation. Then identity spoofing and impersonification. Attacker can try to forge a person's identity or even an agent's digital identity. One agent can also be attacked by another agent, another spoofing agent, to bypass the authentication, allowing them to extract data or manipulate workflows under the guise of legitimate agent or user. So, what could be the mitigation strategies for these agentic vulnerabilities? So, for example, for prompt injection, we have to first validate and sanitize the inputs. We should use strict prompt templates, isolate them. We should employ guardrail tools to protect the injected instructions, limit agent actions, okay, and a human approval before sending in any prompt. Okay, this is a human in loop, just a test, just a mitigation strategy of how your agent is behaving. Okay, adversarial evaluation. Evaluate your models on opposite prompts, on sending out of context prompts, edge case prompts. Okay, designing a trip to trip up your application, to trip up the model. So this is all before production. It could be pre-production tests. For data poisoning, we have to have more control over the data quality, curate data sources for training and knowledge, check if each and every document you are providing as a data to the LLM, to the MCP server, you have to get to know what that knowledge is feeding into the system. Monitor knowledge bases if there are multiple sources of this data. Okay, content scanning, validate model output against known good data, periodically retrain, refresh on clean data, and assemble models to reduce single data influence. Employ embeddings which are clear, which can catch outliers before using the vector DB. Then agent manipulation and coagulation. So here, a phenomena called as zero trust is used. Zero trust is called as an agent cannot blindly trust another agent. Somebody should be there in between them to validate each other's responses. You cannot feed directly one agent input into the other unless and until you are sure that they are risk proof. There is no chances of failure. You need to have a layer of security between them. So unique identities, least privileges per agent. You cannot provide all the permission to one agent. One agent which is going to book a flight is just going to book a flight, not more than that. So this is reduced permissions, least privileges. Redundancy consensus require important decisions to be agreed by multiple independent agents. So if a whole application is making very important decision, there should be consigning parties to agree to that decision. There should be a list of agents who should agree to uh, do that kind of important decision. Then going to the tool misuse, enforce allow list for all the tools. Again, permissions, APIs have API key, clients, make them restricted, block everything else. Their scope should be defined. Uh, Confirmation steps for high risk tools. Always test in the sandbox environments. Do not always go directly to prod. Okay, real-time monitoring of the agent tools. Even if you are checking in the sandbox, check each and every step agent is taking. Okay, maybe integrate some alerts into the system, some notification into the system, and even logs. You have the backend logs, observe them. Okay, then secrets for data leakage, design pipeline which are clear, determine the triggers, don't rely solely on AI interpretation. Where AI summarizes or interpret results, keep a raw result and do basic checks. Fail safe conditions. Okay, if AI conclusion conflicts with the simple heuristic search, halt and escalate. If you think an AI is doing something suspicious, you have to stop there and then within production or pre-production environments. And some CI/CD logic checks. You should never hard code your passwords, your secrets, mask everything. Sensitive data should be masked. Even if it is test data, mask it. Monitor the AI output for sensitive patterns like URLs, personal data, sanitize everything before integrating it into the system. Okay, then these are the mitigation strategies for agentic vulnerabilities. Identification and tokenization of identifiers, protect clearly sensitive data like social security, credit card numbers by tokenizing them in the workflow. Field level encryption, encrypt the rest of the unstructured data or embeddings and metadata that may still hold sensitive information. Context aware access control, decryption and masking. Decrypt and share only what is necessary, basic text, when it is necessary while reducing the sensitivity because of masking. Then treat prompts and retrieve data as untrusted. Everything which is uh, out of knowledge, always treat them as untrusted. Always treat user prompts and publicly indexed data as untrusted inputs to avoid potential security vulnerabilities. This include validation, sanitizing, carefully monitoring any input before it is in the downstream processes. And there are certain architectural safeguards also which dev teams could use. For example, least privilege for agents. We already discussed limit what an agent can do, what they perform. Any agent which has the task of test analysis, for example, should just have read access of the logs, no other than read access. Use fine-grained IAM rules, identity access management rules, and decide their scopes beforehand so that even if an agent is strict, they can lack the permission and cannot do any unexpected outcome. Sandboxing and isolation. Run AI agents in isolated environment, in test environments. For example, if an agent needs to execute code, do it in a sandbox environment first. Contain it with limited network access or with whitelisted network calls. So this way, if the AI tries to execute a malicious payload, it's contained within the test environment. Then validating and checkpointing of actions, introduce architectural guardrail layers that can catch potential dangerous actions before they fully execute. For example, if an agent is about to push a code change or initiate a deployment, route that action through a checkpoint. It's an important action, right? So any important action can go from human layer. Introduce a human feedback and then perform that action if he agrees to it. This could be as simple as requiring a second approval for sensitive action or human or any other secure agent to do that. Then secure supply chain action. So treat the model, dataset, agent software as critical agents. Okay. Use cryptographic signing for all these containers. Integrate verification hash, checks, attestation on all these third-party resources. Okay, these things also depend on the external teams. The IAM team will do the permission, the security team, clouds team will do all these encryption mechanisms. Okay, limit persistence and memory. Many agentic AI which use memory or conversational memory, they retain the context of older conversations. So to mitigate memory poisoning, limit how much they can hold. Maybe put a limit on, you can just interact from 10 MB, which is very small memory. For example, flushing out the agent's external extra memory at the end of each pipeline, rather than letting the instructions persist overrun. So in this case, even the operational cost of running the query and giving out the results, that will also minimize, and memory poisoning chances will also go very less. Then operational considerations. The system support real-time feedback loops, allow analysts to flag missed fraud cases. These labeled events, use always labeling. Anything which is out of any behavior which is out of scope is considered as operation failure. Use periodic retraining of the model, find out drift mechanisms of how a model can drift from intended result. Similarly, agent drift mechanisms are also there in place. Statistical anomaly detection. This is a AI/ML based detection algorithm where you can use various statistical algorithms to find out how your agent is misbehaving from a deterministic output. Okay, these outliers are within the range, and you have to make an agent deterministic enough so that it does not lie within this anomaly detection rules. There can be various rule-based anomaly detection. These techniques detect subtle problems with data quality, like null, not null, positive integer, would otherwise ignore any flag any fraud or data drift or outlier reporting. And it also monitors high frequency data streams like sensors data, which is used in, again, autonomous vehicles. You have to use cameras, GPS, MUI, internal systems in order to make a decision. So by using these statistical models, we can flag data points in sequences that deviate from the actual intended normal behavior. And zero trust interactions, as I already discussed, never assume one agent trusts another by default, require a strong authentication between agent to agent communication. Each agent should have a unique identity or API key, which is just exposed to the connecting agent. And if any malicious imposter shows up or an agent starts sending unexpected commands, you have to halt everything, block it. Alongside authentication, encrypt inter-agent messages also. Okay, so these are some of the mitigation strategies. And if you see, this is a pipeline which is showcasing a risk model and a secure model. So starting from input query, we have directly sending it as a malicious or sensitive data, but instead of that, we have tokenization of identifiers in place, and we are refining our query in order to, if user is sending out directly his name and email, so we are masking them. The model has the capability to mask it, hide it, and then work on the request. Again, going forward, we have embedding data from RAG. So this embedding data also is again checking a second layer of security, secure query on the encrypted data. Okay, if it has external systems connected, it will also secure them. Then agentic retrieval, for example, here in place we have context aware user end user specific access control. We don't have the access of any third party database here. We just have whatever databases we have. Those are also logged. Those are also permission requested. If the agent really needs their access, it needs to unlock them from my API key and then interact with them, decrypt them and then interact with them. Okay, so you can get the output here is context aware de-tokenization with masking. So in order to read the content, the last layer has to do de-tokenization, it has to do decryption and then send it to the user. Whereas this is the risky model where we do not have any PI leak security embedded. We do not have any locking, any permissions, direct database access. We do not have any LLM locking here. If the LLM is thinking, it is directly taking user input, user email, using user credit card. And if some attacker has introduced into the network packages, it will leak out all the information. Okay, any questions? So yeah, thank you for the session today. You can follow me on LinkedIn. You can send me your testimonials. Send me if you want to have a QA session on any topic. We can include that into our next conversation here. I'm also writing a research paper on the same topic which we have discussed. You can follow me even on ResearchGate. And if you want to connect, open for connections. And thank you, everyone. If you have any questions, please go ahead.
Okay. Thank you so much for that great session. Thank you very much. That was really a great session because there are so many things I do not understand before that I got to understand in this. I would like to ask some questions permanently. Yeah, I would like to ask some questions if you don't mind me asking. So yeah, you were talking about prompt injection. So I would like to know the difference between injection and prompt hacking. Yeah, prompt injection and hacking. Are they the same? Is there something we need to know about it? Um, yeah, that's my question.
So, prompt hacking is a mechanism where we are controlling, where an attacker is controlling input user's query. Suppose you have put in the chat GPT application, find me the best restaurants near me. But the application has been exposed to an attacker. They know what people are requesting, and the application in turn is asking you, can you give me your credit card details? And there is no way an application a model will behave that way. So that means a hacker has been introduced into the system, into the data packets, and it is trying to modify your question to the model. This is called as prompt injection. A prompt hacking is output retrieved from the model has been modified. So these are two different types of hacking into the conversation. One is from input perspective, one is from output perspective. Both are a different way of how attacker deals with it, but both require encryption and decryption, and both require additional LLM knowledge to respond over it. So yeah, this is both of these things together are called as prompt poisoning also, if both input and output are injected with uh, different requests.
Great, great. Thank you very much for that answer. Meanwhile, if anyone has any question, you can always raise up your hands and the floor would be yours. I have another question if you don't mind. Okay, you were talking about MCP. Can we know what problem MCP solve for multi-agent system?
Yeah. So if you see an agent is trying to interact with different parties here, and all these different parties have a different communication protocol, right? So if you see Joy Air here, it has flight number, it has origin and destination. And similarly, we have Airgo, which has flight and start and finish. So an agent needs to know what is start finish here, what is origin destination here. It does not have a complete vocabulary, right? Because it's a system. If you feed just origin and destination, it will completely reject this whole party. So an agent needs to understand all the options in order to give you the best results, right? So this intercommunication problem is solved by MCP because it acts as a layer of communication, and a unified communication means it's a protocol in itself. It will interact with different, either you have 5, you have 3 portals, you have number of portals. It will interact with a unified way, and the agent will just have to get this information from MCP and not directly from third party. So in a way it is secure, in a way it is safe communication, it is understandable communication. So all these things are resolved by MCP. A standardization layer, a security layer, there is no vendor lock-in. You can have your results coming from n number of sources. That's how MCP eases out the communication.
Okay, thank you very much. Thank you. One last question before we go. Um, so can you tell us? I just want to know because I know I've got to hear about traditional API gateway. So I don't know the difference between MCP and traditional API gateway. If you don't mind, can you enlighten us about that?
Yeah. So traditional API gateway will interact with just one party, right? If you have a traditional API gateway, for example, a payment gateway, you have a credit card. All the parameters are credit card number, CVV, expiry, everything will go to that payment gateway. Payment gateway will perform the transaction, give you the success or failure message. That is a payment gateway. But a MCP is a communication gateway, and both context also. There is context of understanding input requirement, and there is interaction protocol also. So a payment or API gateway will just understand one thing, a API contract. If you have an API contract with one party, it will understand that. But a MCP here will understand multiple API contracts, also have a context of user requirement. What is user asking? If user is asking for a cheap flight, okay, a very inexpensive flight, it will book that only. It will compare, it will do the comparison. So MCP has additional values, and it will just work for a model, LLM model. It will not work for any non-AI application.
Okay, thank you very much for the answer. It's really understandable, and we really appreciate the fact that you taught us and break down every single slides of yours. Thank you so much, Savi. Guys, let's appreciate her. Please, let's appreciate her. Drop your emojis to show that you really appreciate and enjoy a session. Thank you so much. You can always follow her or connect with her on LinkedIn. That is Savi Grover. Yeah, she's one of our best facilitator in Texas quarters, and we are so glad to have you here. Thank you very much, Savi. Thank you for your time with us. So this before we go, yeah, I will not forget. I remember we have something wonderful coming up for Texas Quarters Lagos this month, and don't worry, it is coming up. We're going to be telling you guys about it. And yes, our founder have a gift for us. If you don't know what I'm talking about, then you have been out of it. I don't understand how you be in a community like Texas Quarters. I not know what is going on in town. We have something wonderful. Our wonderful founder has brought up with us. We have ready to learn, and it is for everybody. Everybody, yeah. We are going to be bringing in professional, and it will be a virtual meeting, but the remaining one would be for till next year. Yeah. So what we are going to be doing, we are going to be interviewed and checked out, and we are going to be checking you out if you are a junior, a newbie, a professional, and we are going to be adding you guys to a group. And to be honest, it's a very big load of interesting things. During this time, you're going to be exposed to how to answer questions in interviews. Your CV, we are going to review your CV. We are going to look into what you're supposed to be doing for your growth in as a tester, and guess what? After all these great things, we're going to dispense you out to the marketing world. Trust me when I say your CV is great. Once your CV is great, trust me when I say you have gotten a job. We are going to be posting jobs for you guys, and to be honest, you guys are really going to enjoy this session. Yeah. We're going to be posting about this tomorrow, so look out for it. In fact, we already posted it. You can always go down to our social medias and check out the there's two other posts. Yeah. So the two posts before, you are going to see it. Or if you're in our Slack, it is easy for you to get it. Yeah. So you can always go to the website to register. Yeah, and we look forward to see you guys there. If you did not date there, if you did not date there, what what's your aim? Okay, so yeah. And then I would like to also remind us about the product dive. The code will be dropped tomorrow. The code of the we were given let me call it bonanza. If you don't know the meaning of bonanza, that is Savi. Yeah, we were giving bonus. So the money for Texas Quarters community is going to be reduced through our code, and we are going to be dropping that code tomorrow. So you have to look out for the code. And yeah, I'm going to meet you at product dive, even after Lagos get together. I really look forward to see you at product dive because I'm tired of seeing only names of people. Okay, guys. Yeah. Thank you very much for joining us. Thank you very much. This will be the end of our session, and we're so glad to have you here. We're so glad to have you here, and we love you in Texas Quarters, and there is nothing you can do about it. Yeah, this is coming from more of Texas Quarters. Thank you very much, everyone. Thank you. I hope we have a great weekend. I love you guys, and there is nothing you can do about it. Meanwhile, we'll have to say thank you once again to our facilitator, Savi Grover, for that wonderful session. Bye, guys. Have a very nice weekend. Bye.